We want to welcome you to the Dallas Independent School District STEM Environmental Education Center virtual field trip. We want to say a very special welcome to Arthur Kramer, M.T. Riley, Gabe Allen, Lakewood, Ignacio Zaragoza, Cesar Chavez, and Pleasant Grove ISD, all from the Dallas ISD. Thank you for joining us on this beautiful, beautiful winter afternoon. We hope that your students learn something, but we also hope that they have a good time. Teachers, if you're watching and you have not signed up, please go to www.tiny.cc/3-5 registration. Sign up for us, please. We appreciate it. Program today, weather and the water cycle. During this virtual field trip, students will predict changes in weather. Students will also describe the continuous movement of water above and on the surface of the earth through the water cycle and explain the role of the sun as a major source of energy in this process. Mr. Ramirez will tell you all about temperature. Ms. Schramm talk about the wind, the water cycle. Mr. Dominguez predicting changes in the weather. Mr. Monroe, we certainly had some of those lately, haven't we? And Mr. Copeland, a guest speaker, will talk about Texas weather and climate. Students, you cannot ask a question during this program, but you can go to www.tiny.cc/question-answer, and we will send in your questions, and I'll do my best to answer them during the program. If not, I'll send them to your teachers. Now I'm going to stop sharing my screen, and Mr. Monroe, Ms. Ramirez is going to tell you about temperature.
These are my two dogs, Abby and Toby, playing in the snow last year. What temperature do you think it was? In this segment, we are going to learn all about temperature. Hopefully, by the end of this segment, you'll be able to answer these two focus questions. The first is, what tool measures temperature? The second is, what object in space is most responsible for hot or cold temperatures here on Earth?
Temperature is simply how hot or cold it is outside, and we know that we can measure temperature using a science tool called a thermometer. Notice on our thermometer, it has degrees Fahrenheit and degrees Celsius. There is a liquid inside the thermometer. It's normally red, but it can be any color. When that liquid gets hot, it will start to rise. And when that liquid cools down, it will start to drop toward the bottom.
The energy that the Earth receives from the sun is the basic cause of our changing weather. Solar heat warms the huge air masses that make up our weather systems. Energy from our sun is very important to Earth. It warms our planet, heats the surface, oceans, and the atmosphere. The sun also provides light, heat, and solar energy. The sun provides the major source of energy for water to move through the water cycle. Sunlight heats up water near the ocean surface, causing evaporation. We experience seasonal changes in temperature due to the Earth's 23.5-degree tilt and its revolution around the sun. In Texas, summers are usually hot and dry, and our Texas winters are usually mild compared to northern states. Here at the EEC, our ponds typically dry up during the summer, causing animals to either die or migrate. Here is a thermometer located at our school. What is the temperature reading? This reading was taken during the last freeze we had on January 27th. Teachers, feel free to pause the video to give time for students to read the thermometer, but for the sake of time, I'm going to go right into it. On this day, it was about 26 degrees Fahrenheit. That is super cold. It was actually below freezing. The blue line on this thermometer marks the freezing point, which is 32 degrees Fahrenheit or 0 degrees Celsius. It was so cold that day that the duck pond actually froze. So you can see the sticks and leaves that froze in the water. The water changed phases from a liquid to a solid. So temperature is important to study because it affects us, plants, and animals. You can see our cute little ducks are running around. How do you think our livestock were impacted by the freezing temperatures? It was so cold that day that the water bowls for our livestock actually froze. We had to go outside and break the ice with a stick. Beneath the layer of ice, there was water underneath. Think of it as when you make ice cubes. You place liquid water in a tray and place it in the freezer. The temperature is decreased in a freezer, which removes heat, causing the water to freeze. Now, this video was taken during the winter time, but how do you think our temperatures will change once we enter the spring or even summertime? Also think about how will those changing temperatures impact our plants and animals? What are some seasonal changes we might see? In this next part, I'm going to walk you through how to make your own thermometer. It is super simple. All you need is a straw, Play-Doh or a glue gun, a mason jar with a lid, water, rubbing alcohol, and cooking oil. As always, make sure you ask an adult for help. The complete instructions to make this thermometer are online at littlebensforlittlehands.com. It is important that when you make this thermometer that you make sure you have a tight seal between the Play-Doh and the straw. If your Play-Doh does not securely hold down the straw, the liquid will not move. It needs to have a tight seal in order to work. I placed the thermometer outside during our snow days when the temperature was in the 20s. What do you think is going to happen to the liquid when I place my homemade thermometer on top of our wood-burning stove? So observe the movement of the liquid in the straw. What do you notice? Now pay particular close attention to the top of the straw. Hopefully you notice that when the liquid gets warmer, it's starting to rise. Now what do you think is going to happen when I run outside and place my homemade thermometer back outside in the freezing cold? Hopefully you're noticing that when the liquid loses heat, it starts to move it down the straw. This is very similar to how a real thermometer works. When the liquid warms up, the liquid will start to rise toward the top. When the liquid loses heat, it will start to contract and move back down the thermometer. I do have a challenge activity for y'all. Record and graph the temperature for your location for a month. What patterns do you notice? So that's all I have for you guys today on temperature. We're going to give it back to Dr. Gorman. Questions.
Thank you, Mr. Maris. And we have a couple of questions. Who invented the thermometer? Besides from Ms. Ramirez, the invention of the thermometer is generally credited to the Italian Galileo. Now you'll get some arguments on that if you go to different research things, but the general consensus is Galileo invented the thermometer. And now Ms. Schramm is going to tell you all about the wind.
Hey friends, good afternoon. It's me, Miss Schramm, and we are talking all about the wind and windy weather. So let me get this little thing started. All right, whoop. Here we go. All right, windy weather. So at the end of my little section, you'll be able to observe, measure, record, and compare day-to-day weather changes, including wind conditions. So I got two little pictures here. One is me with some of my chicken friends here at the EEC. Doesn't have much to do with wind, I just like them. And then I have a picture of me flying a humongous dragon kite on a windy day in Galveston. So I definitely recommend, if you do find yourself in a windy day and in a big area like the beach or a field, flying a kite can be super fun. Sometimes it's challenging, especially if you have a crazy shaped one like that dragon one, but it can be pretty rewarding once you see it finally flying. So anywho, first we're going to talk about how you can tell if it's windy or calm. Now this is very, very simple. This is our first tool we're going to use, and it just grows right here in nature. So if you want to know if it's windy outside, all you got to do is look at the trees. So we've got our palm tree with the palm fronds spread out, soaking up the sun, and you can tell that it is a calm day there. Then on the right, you can see the wind is blowing all the palm fronds over to one side. It looks like the tree is almost bending, so you know it's a really windy day. Another really simple tool that we can use to tell what the weather is going to be like is just by looking at the flag outside of your school or outside of other buildings. So if the flag is laying flat and not blowing anywhere, not moving, you know it's going to be a calm day. And if you look at the flag and it's flapping in the wind, or sticking straight out, you know it's going to be a windy or a very windy day. So those are our basic, very basic. You don't even have to get out of your seat. You just look out the window and you could tell if it's windy or not, and relatively how windy. Now, when we start using more weather tools, we are going to be able to tell which direction the wind is blowing. And beyond just feeling, oh, it's blowing this way, we're going to use our cardinal directions to tell us which way the wind is coming from and which way it's going. So if you look at the far right, you can see a picture of a weather vane or a wind vane. And you probably have seen these before if you've been to a farm or a ranch. A lot of times they have a farm animal on top. This time they have a horse on top. Then there's an arrow, and then you'll see 4 important letters, NSEW. That stands for north, south, east, and west. So those are our cardinal directions. Those tell us which way we are traveling, the wind is traveling. So that is important because if you are working on a farm or a ranch, say you needed to work in the field or work your animals, move them from one area to another, and you look up and you see this humongous big dark cloud. Well, you might want to know if that cloud's coming towards you or moving away from you. So those wind vanes can be really helpful to predict what weather is coming towards you. So you can also make these in your classroom. I've made them before. It's fairly simple. All you really need is a thumbtack or a sewing pin, straw, a little bit of construction paper, and a pen or pencil to hold it all together. And then also using a compass to make sure that you have your cardinal directions lined up to where they actually are. And this first example that I've made before uses the cardinal directions, and then the other one is just relative direction and it doesn't have the letters. So it's up to you if you want to make one of those on your own. It can be pretty fun. Okay, so the next tool we're going to use is an anemometer. An anemometer tells you how fast the wind is blowing. And there's another example of how you can make one your own self. So this one's not actually going to give you a reading, but it will show you how the anemometer functions. So they used, it looks like little yogurt cups or little coffee cups. And how this works is these bowl-like discs on the real ones and on the student-made one, they turn because of the air, right? So wind is just moving air. So that moving air presses against the disc and pushes it. And so it starts to turn, and all 3 of those discs are being pushed and turning around and around, and a gear inside will turn with it. And then there's a little meter at the bottom to tell you how fast that gear is turning. And that will give you a reading in miles per hour. So that's how we measure wind speed. How many miles will that moving air cover given an hour, right? So miles per hour. And let's see. This is an example of the Bufton Scale, and this can help us kind of make sense of those readings. So say your anemometer says that it's 15 miles per hour wind that day. Well, that's all well and good if you're making a graph or a chart, but what if you're just trying to figure out what's going to happen in your day? So this, according to the Bufton Scale, would be 15 would fall under a moderate breeze, and that would be at a level 4. But once again, okay, yes, it's a Bufton level 4, but what does that mean? Well, what you're going to be able to observe, or what you're going to be able to experience outside, is branches are going to be moving, any dust on the ground or papers on the ground are going to rise and be blown away a little bit. So you can use the reading to get to what you can expect, but you can also make observations and kind of predict what level it might be at, or what generally mile per hour you have. So let's see. I wanted to share this with you because it's a visual version of the Bufton Scale, because that is a lot to memorize, that whole scale. But this is a nice way to visualize. It's a little blurry, but it still works. What those different numbers mean. So we start at 1. They have our little simple weather tools here, the tree and the flag. you can see the palm tree is all spread out, the flag is resting, and so you can tell there's not much breeze, there's not wind at all, and sure enough, it's 1 to 3 mile per hour winds. Something else important to look at is the chimney. So when there's no breeze and you're lighting a fire, the smoke will rise just vertically, it won't move. Now you'll notice as we increase, those palm fronds, the smoke, and the flag starts to move. So just by using those simple observations of a tree, smoke, or a flag, you can start to tell quite a bit about the wind speeds. So of course it starts to blow and they start to move more and more and more until we get to a level 6. So if you ever look outside and the flag is sticking straight out, you know you're at a Beaufort level 6 or beyond. So the smoke is blowing almost completely horizontally, and that happens at 25 to 31 miles per hour. Now, as it increases, of course, you're going to see a lot more damage. And the Beaufort scale actually goes all the way up to 12, which is 73 plus miles per hour. And you can see our poor little house and our tree and our flag are all gone. So at that point, you're probably not worrying about what number on the scale it is, but there we have it. It's a level 12. So hurricanes, oh, I meant to say at level 12 or even 11 and 10, that's when you're going to see your major storms like hurricanes and tornadoes. So hurricanes are also measured in a more simple system. Instead of going from 1 to 12, they are measured 1 through 5. So you might hear on the news when you hear about hurricanes in different areas, category 2 or category 4. And basically all that does is tell you how severe and how serious the hurricane is going to be. And once again, we've got our miles per hour. So a level 5 with the most devastation is going to be 157 mile per hour winds or even higher. So the hurricane wind scale has also that little visual to help you kind of picture what those different categories would actually mean in real life. Then we also have the tornadoes. So the tornadoes use a very similar system. So instead of like the category 1 or 2, they have the enhanced Fujita scale. So on the news, they might refer to it as an F1 or an F2 tornado. So that's what it's in reference to, the number on the enhanced Fujita scale, EF scale. So, but usually I remember hearing on the news them saying like, oh, it was an F3 that touched down in such and such area. So that's what you might be hearing on the news. And then we've got the corresponding miles per hour. So an F5, which is the most devastating type of category of tornado, is 201 plus miles per hour. So my little challenge to you, which is not popping up, but that's okay. So my challenge to you is that if you are able to go outside later today, or even if you're able to look out your classroom window, kind of look at the trees or the flag, whatever you can see outside, and see what kind of movement you see, and try and guess what scale or what number on the scale you think the wind might be. So I'm looking out here and I see pretty much nothing. So that kind of makes it easy for me. I'm thinking it might be a level 1 or 2 because I do see some branches moving, but not quite. All right, so that's all I have for you today. Thank you so much for joining us, and I will see you next time.
Thank you, Ms. Round. Question came in. What are 2 more uses for the wind? Out here we have at the Environmental Center, we have windmill that actually pumps water out of the ground, and we use it to water our livestock, and we also use it to try to keep the small pond full of water. And out in West Texas, they have the huge windmills that generate electricity, and there's a recreational use for them. You can fly kites. I had trouble saying that one. And you can also sail boats. Okay, now thank you for that. And Mr. Dominguez is going to tell us all about the water cycle.
Hey guys, it's Mr. Dominguez. I hope you guys are staying warm. We definitely had some pretty interesting weather here in Texas. We had some sleet, we had some snow, we had some freezing rain, and it made me think about the water cycle, and that's exactly the topic for today's virtual field trip. And you may be wondering, what in the world is Mr. Dominguez showing me right now? Well, since it's pretty cold, I have to keep my reptiles indoors, and this is Teddy's habitat. He is a redfoot tortoise, and redfoot tortoises require a very high humidity level and plenty of rain. So, unfortunately, that can't happen here in Texas. So, what I have to do is I have to simulate rain. So, as you can see here, I'm spraying him down because he needs that rain, he needs that humid environment to thrive. Uh, but what I'm going to do for you guys today is give you guys a pretty quick demonstration that is going to explain what happens in the water cycle and how the water cycle gives us rain and other forms of precipitation and replenishes our fresh water supply. So let's get started with this portion of your virtual field trip. All right, guys, before we get started with our demonstration, there's a couple of things that I want you guys to know about the water cycle. One, the sun is the driving force that makes this water cycle possible. Without the sun's heat energy, we would not have evaporation. Two, transpiration from plants also plays a key role. So, transpiration simply is the release of water vapor during the process of photosynthesis. So we know that plants need water, but not all that water is used during those metabolic functions and is released into the atmosphere as water vapor. So those two things are very important to the water cycle. So to better visualize what happens in the water cycle, let's get started with our demonstration. All right, guys, so for this very simple demonstration that will replicate what happens in the water cycle, you're going to need some ice, some boiling water, a container with a lid. If you don't have a lid, you could use saran wrap. So in this demonstration, what we're trying to do is recreate what happens in the water cycle. And the first thing that we need to understand is the sun powers the water cycle. So normally what would happen outdoors, is the sun's heat energy would evaporate water. But since we don't have the sun indoors, what we did is we microwaved some water, and I'm going to be careful. So if you do this in the class or at home, you're going to need some protective equipment. Mr. Dominguez doesn't have his gloves today, so I'm going to use a napkin, and what I'm going to do is I'm going to pour that boiling water into the container. And as you can see, we already started to get some condensation right away. So that happens when water vapor touches or comes into contact with a colder surface, or in this case, in the water cycle, it would be that colder atmosphere. What we just represented was the sun's heat energy evaporating the water. So it could be water from a stream, from a lake, a pond, the ocean. So that water is being evaporated. So as that water vapor rises, so let's close our system. So as you can see, I already got some condensation occurring there, but the ice is going to represent our Earth's atmosphere. So this is going to be the colder atmosphere, and as that water vapor condenses, it starts to accumulate. So it starts reverting to its liquid form. And as that happens, as that accumulation occurs, eventually, thanks to gravity, will fall back down to Earth as precipitation. And precipitation takes different forms depending on temperature. So this past weekend, we got some different forms of precipitation. We got some sleet, snow, freezing rain. And it was pretty cool to see, because in Texas, we usually just get plain old rain, right? So let's give this a few more seconds so I can show you guys the condensation that occurs. So in a nutshell, this is what happens in the water cycle. So you have evaporation powered by the sun's heat energy. So that water evaporates, rises as water vapor into our colder atmosphere. condensation occurs, and eventually that accumulation of liquid water falls back down to Earth as precipitation, thanks to gravity. So let's see if we have condensation, and you could give this a couple more minutes and see for yourself. Eventually you would start seeing those droplets of water fall back down, but in the interest of time, let me just show you guys that that precipitation that started to form, or the water droplets. So as you can see, where the ice, where that beaker of ice was, you get that ring of water droplets accumulating. So this is a pretty easy and fun way to simulate the water cycle. I hope you guys enjoyed, and enjoy the rest of your virtual field trip.
Thank you, Mr. Dominguez. And we did have a student wants to have a very simple definition of the water cycle. Okay, the water cycle, the continuous movement of water on, above, and below the surface of the earth. And now Mr. Monroe is going to tell you about predicting change in the weather.
Good afternoon, students. We're looking at predictions and forecasting the weather. Boy, that is a very large challenge for those very special scientists that we call meteorologists. And I'm familiar with a couple of them. I watch Channel 8, which my favorite meteorologist on Channel 8 is Pete Delkus. And then the other guy that I pretty well know, he's on Channel 5, and that is David Prinfrock. Now, those guys have to do a lot to give us those predictions and forecasts. They have to read a lot into some information that is gathered. Actually, what I might say, they observe and they measure atmospheric conditions. And Ms. Schramm has already gone over some of the instruments that we use to measure different weather conditions, such as the anemometer, the thermometer. Well, meteorologists use those same things to record data, weather data. But they also use satellite images, and those satellites are above the Earth's surface looking back at the planet Earth, and they can gather weather data from that. And then they also use radar. And over the years, radar has improved. The big improvement with radar came when they developed Doppler radar, which Doppler radar, it can locate precipitation, determine the type of precipitation, how intensity it is, and the direction of the precipitation is moving. But you know what? To really help you guys understand about predicting and forecasting the weather, and another very important tool that they use, I've got a short PowerPoint that I want to share with you. And while you're watching the me sharing you with this PowerPoint, I want you to think about a couple of things. In fact, I guess you might say it's another challenge. It's a challenge for you. How do meteorologists predict the weather? Because you know what? If they hadn't, we probably would have had some real bad conditions here last week, because we were warned about this Arctic front coming in. And so a lot of people, they prepared for it ahead of time. And that's why predictions and forecasting the weather is very important. Also, the last tool that I'm going to be sharing with you that meteorologists use, that is the weather map. I want you to think about how important or how they use that weather map to help them make predictions. So let's get started. Let me share my screen with you. Weather map is a very important tool that meteorologists use. When they collect all that data, what they've observed and what they've recorded from the instruments, the weather instruments they have used, guess what? That weather map becomes an area that they're going to be using to record that information. They use the information they get using weather tools to make those weather maps. This is an example of a young lady that is a meteorologist. And I can remember when I was a very young person, I used to think that a lot of the people that came on to give the weather report, they were meteorologists. Later on, I was a little bit disappointed to find out they were just actors playing the part. But the meteorologists that we have today, they are real scientists. Weather maps show the weather over a part of the Earth's surface. It helps meteorologists forecast the weather. It shows what the weather is like at a certain time, such as even right now. Weather map would look something like this, and we see a lot of symbols, a lot of lines with bumps and triangles. We see the big letter L, we see the big letter H, and down in the Gulf of Mexico, we see a symbol that looks like this. And what that symbol indicates, that is a symbol basically that means there's a hurricane. Weather maps help scientists make predictions about what the weather will be in the future. A prediction is a guess about what will happen in the future. A weather map will show temperature and precipitation. It may also show other types of weather data. It will also show a list of symbols called a key. The key tells you what the different symbols mean. Weather maps show movement of air masses. Now, an air mass is a large body of air with the same temperature and humidity throughout. Same characteristics. Humidity is the amount of water vapor in the air. You heard Mr. Dominguez talk about the water cycle. He mentioned about the gas form of water being water vapor. Water vapor is all around us right now, even more so in our atmosphere and in our air. Humid air contains a lot of water vapor. An air mass can cover thousands of square kilometers. Boy, a lot of miles, guys. There are 4 basic types of air masses. There's cold and dry, cold and humid, meaning it's got some moisture, got some water vapor in it. Warm and dry, very little water vapor in that. And warm and humid, meaning there's a lot of water vapor in that particular air mass, or that type of air mass. On a weather map, these are the symbols that you might see. You might see for a warm front, you'll see a line with bumps, half circles, okay? For a cold front, you'll see a line with triangles. Stationary front, you'll see alternating triangles and bumps. And then an occluded front is one that we don't see very often here in North Texas, usually up around the Canadian border. Now, a front is a place where 2 different air masses meet. Triangles show a cold front. Half circles again show a warm front. The triangles and half circles point in the directions the front is moving. Remember that. It shows the direction the front is moving. Now, cold front, a cold air mass bumps up against a warm air mass. Strong storms happen at cold fronts. Thunderstorms are likely in warm weather. In winter, snowstorms are likely. When a cold front passes over an area, the temperature does what? Drops. Now, here we have an image that shows a cold front coming in, and we can see the arrows of direction, and we can also see the line that would be representing that cold front on a weather map. The triangles are facing the direction that cold front is moving. On a warm front, warm air mass meets a cold air mass and slowly rides up over. There's a tendency for warm air to rise and cold air to sink. Sheets of gray clouds form at a warm front, on warm fronts, and often bring rain. After a warm front passes over an area, the temperature does what? It rises or goes up. Here we have an image that shows the warm front. And you can see the line with the bumps. The bumps are facing the direction that the warm front is moving. And we can see that the warm front is beginning to rise over the cooler air, creating the clouds. A stationary front. This forms when two air masses meet and they stop moving. Clouds and precipitation form at a stationary front. Looks like that on a map. Now you can see the bumps, they're facing one way, which is indicating the warm air. And you can see the cooler air, which is represented by the triangle, is facing the other direction. So there's no true direction that this frontal boundary is moving. And basically, it looks similar to what this image looks like. Weather maps also show air pressure. When we talk about air pressure, we're talking about how heavy or light the air is. When you look at a weather map, you will also see circles with H's or L's inside of them. A good way to remember what they mean is H stands for happy weather. That means the sun's going to be shining. And an L stands for, well, lousy weather, probably rainy and dismal, maybe even a little snow. So I'm going to stop sharing my screen right there because I'm out of time. But listen, guys, maybe your teacher will get you guys to do something like this. But in the Dallas Morning News, there is one page in the Dallas Morning News that there's always a weather map, and it's in the metropolitan section of the Dallas Morning News. And here is an example. And as we look at this, I wish it was a little closer. I've got it blown up as big as I could get it. But there are L's and there are H's. And where we see H's, there's no precipitation. That means it's fair weather. And where we see L's, if the air temperature is above freezing, we have rain. And if it's below freezing, we've got snow. So listen, meteorologists predict weather by observing and measuring atmospheric conditions, and then they record it on a map. Little secret. Weather patterns in the continental USA usually move from the east to the west. I'm going to turn it back over to Dr. Gorman, so if any of you have any questions, I bet he can answer them for you. You guys have a good day.
Thank you, Mr. Monroe. And why is it important to be able to predict or somebody to predict the weather for you? Well, first off, you know what clothes to wear. If it's going to be 30 degrees in the morning and you got to sit out there on the bus stop waiting for that old slow bus driver, you want to wear some pretty warm clothes. But you also got to watch out for it because here in Texas, it might be 75 degrees that afternoon. So, you know, you want a jacket or a coat, but I wouldn't wear my full winter gear because it's going to be warm in the afternoon. Okay, and maybe you're going to plan some kind of activity. Maybe you're going to plan a picnic Sunday for your family. And you want to look at that 7th-day forecast and make sure it's going to predict good weather. That does not mean it's going to actually be there. There's a good chance that it will, because weather forecasting and weather predicting has improved so much since I was your age. And now Mr. Copeland is going to tell us about the Texas weather and climate.
Hi, my name is Wesley, and I'm a meteorologist with the Texas Commission on Environmental Quality, but we call it the TCEQ for short. The TCEQ is a state agency that protects our environment and makes sure our air, water, and land is protected from pollutants. We also teach Texans about how they can help keep Texas's environment clean. I'm a meteorologist, but you might have heard the job called a weatherman. A meteorologist is a scientist who studies the weather and makes a forecast so we know what the weather will be in the future, which could be the weather tomorrow or the weather in a month. I'm a little different than the weatherman you see on TV. I track weather to study how it will affect our environment, as well as track how it affects air pollution. Sometimes pollutants can make our air dirty, which is especially important to know if you have asthma or other health problems. I make sure Texans know when the air is safe and clean to play outside. We use a colored chart to show how clean the air is. Green is the best and purple is the worst. Typically, we see orange ozone action days in the summertime when there's lots of sunshine and winds are light. They're also more common in big cities where there are more cars. To study the weather, I use weather measurements. Those are taken by air monitoring instruments and by air investigators. They work all across Texas, taking data with handheld monitors, air monitoring vehicles, and stationary air monitors. Their machines can sense lots of different things about the air that we can't see with just our eyes. They can tell us the temperature, pressure, humidity, and different types of invisible particles that are floating in our air. I use the information they gather to decide what that means for the weather and predict the amount of pollution that might be in the air. You can even monitor the weather yourself by using thermometers, rain gauges, anemometers, wind vanes, barometers, and hygrometers. Texas weather is very unique and special. Texas is very large, which means we have different types of weather across the state, even in a single day. It could be snowing in Amarillo while people in Corpus Christi are playing at the beach. In Texas, we have beaches and mountains, plains and hills, swamps and deserts, forests, and, well, you get the picture. Because of these different types of land, we see lots of different types of weather. Some of the types of weather we see in Texas are thunderstorms, hurricanes, tornadoes, snow, and fog. Texas has several different types of weather patterns that we see year after year in our state. Some common weather patterns we see are cold fronts, which are large areas of cold air that move across the state. Cold fronts cause some of the most interesting weather events that happen in Texas. When a cold front comes through, it's pushing the warm ocean air back out over the Gulf of Mexico and brings in the cold mountain air from the north. It happens all across the state as the cold front moves. This is why you might wear shorts one day, but the next day you might need a jacket. Another interesting weather event we see in Texas is hurricanes. They are very interesting to watch because we, as meteorologists, try to figure out where they are going to go. This is important so we can know whether or not it will cause problems for people who live close to the coast of Texas. It is important to know the difference between weather and climate. Weather is what is happening today and the next several days. Climate is the average weather over a longer period of time, like months and years. For example, even if the weather is rainy today, if it is the only time it has rained in the last 6 months, the overall climate during this time period would be dry. At the TCEQ, we track both weather and climate, since they are both very important. Thanks for taking the time to learn more about how the TCEQ helps you take care of Texas.
Thank you, Mr. Copeland. And now I'm going to share my screen. During this virtual field trip, students predicted changes in weather. Students also described the continuous movement of water above and on the surface of the earth through the water cycle and explained the role of the sun as a major source of energy in this process. Ms. Ramirez told you about temperature and thermometers. Ms. Schramm, the wind. The water cycle illustrated by Mr. Dominguez. Mr. Monroe told you all about predictive changes in the weather, and Mr. Copeland, Texas weather and climate. Thank you so much for joining us on this beautiful, beautiful winter afternoon. So if you will, teachers, go to www.tiny.cc/3-5 feedback. Send us a very short form and we would appreciate it. Thank you again. Have a great day.